Okay, so this is the section that we're skipping. I wanted to show you completing the square so that you could understand it and you could see why we don't need to do completing the square, but you're going to eventually have to be able to do it when you get into Algebra 2 some, but mostly into pre-cal. There's a couple of places in pre-cal where you'll have to do it, and I'll remind you again how to do it when we get there. But for right now, I just wanted you to see it once. So this is the one time. Do not write this down. You don't need to remember this. I got a plan. Trust my plan. However, I did want to show it to you. So when you're doing completing the square, the whole point is to get it to look like this, because we talked about how to solve these in section 13.1. How you have to take the square root of both sides and then you can solve it out. That's how you get rid of the square, but that only works when you have the square by itself. So when we have this, we don't have the square by itself. And the process of completing the square is how we get it to look like that. In order to do that, the first thing you're going to have to do is move your number to the other side. So I went ahead and I moved my number to the other side, and this is what I got. Then you have to do the actual act of completing the square, which means you take half of the middle number and then you square that number. Half of 8 is 4, and 4 squared is 16. So I'm going to put the 16 here and here, because whatever you add to one side, you have to add to the other. Got to keep our equations balanced. Now that I have my magical number of 16 in there, now I can go ahead and simplify this side and get that it's x squared plus 8x plus 16. And the other side, 9 plus 16, is just the number 25. Now this I can factor, and when I factor, I get this magical perfect square trinomial. That's helpful. That means that when I factor it, I'm always going to end up with the same thing in both parentheses, which means I can write it now as that perfect square, which means I'll be able to take the square root of both sides because it looks like that, so I can take the square root of both sides. Remember, when you take the square root of both sides, you don't know whether it's going to be positive or whether it's going to be negative, so you have to set it up for both. So I have one side that's set up for a positive 5 and one side that's set up for a negative 5. Go ahead and subtract 4 from everything. You're going to end up with x is equal to 1 or x is equal to negative 9. And technically you should check both of those, but I know that they work. That is completing the square. It's not too terribly hard until you start throwing a lot of things in there, like numbers that don't divide evenly by 2. And then you get all sorts of fractions in there. Plus, there are times when completing the square doesn't always work because you end up with these fractions all the time. And that's not fun. But there is another way, and that's why we can skip the whole completing the square to begin with, because we now have something called the quadratic formula. Okay, don't be as excited about it as you think you should be right now, but I'm telling you, it's really good. So when you have a quadratic equation and you have managed to get it equal to 0, then this will work every time for you to solve for x. Every time, doesn't matter whether it's factorable or not, it'll work. Doesn't matter if it's going to give you something that is unfactorable, it will work. Doesn't matter if it's imaginary, it works every single time. So a lot of times you have to memorize this so that you can use it whenever you need it. Now your question should be, am I going to have to memorize it for the test? Well, absolutely. It is the point of the lesson. So yes, you have to have it memorized for the test. But wait, there is a song. And because I love you, I'm willing to sing you that song one time. It goes like this. Negative b Negative b plus or minus the square root, plus or minus the square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. That's it. That's the quadratic formula. If you sing it enough, it'll be with you forever. You need to make sure that you definitely use this when it doesn't seem like you can factor, because that's the whole point of it, to have something there when it doesn't seem like it's factorable. Also, you don't want to leave any decimals in your answer. Always give them exact numbers. Never punch in your calculator what the square root of 3 is. Always just leave it as a square root of 3, because the square root of 3 is an exact number, but a decimal is not. Decimal is just an approximation of what it is. So let's look at a problem. Let's say this is our problem. Now I know what you're thinking. That's factorable. Well, it's really not. Well, okay, it is. But if we didn't know whether or not it was factorable, we could still use the quadratic formula. And I'm going to show you what your answers are going to look like. So you'll be able to tell, oh wait, I should have factored that. Could have saved me some time. But that's okay, because you need to practice with the quadratic formula, so you'll be able to do them whether they're factorable or not. Now, the second thing you should be thinking to yourself is, those aren't x's, but you and I know that it's okay that they're not x's, because m's work the same way as x's work. It's a quadratic, it'll work. Instead of having an x here, we just have an m there, and everybody breathes fine. The first thing you need to do when you're doing the quadratic formula is figure out what a, b, and c are. A is the coefficient on your square term, so that's a 1 here. B is the coefficient on your singular term, so that's a 6 here. And C is the coefficient for your last term, that's an 8. So now I've got my A, B, and C. Since we have to memorize this, you should write it every time you use it. That's how you memorize things. Negative b plus or minus the square root, b squared minus 4ac, all over 2a. So, all I gotta do is plug stuff in. My negative b is going to be the opposite of whatever my b is. If my b was negative, I'd make it positive. Since my b up here is positive, that'll make this negative 6. Plus or minus square root. B squared means that'll be 6 squared. Minus 4 times a, which is 1, times c, which is 8. All over 2 times 1. Now all I got to do is math. So x equals negative 6 plus or minus the square root of 36 minus 4 times 1 is 4 times 8 is 32 all over 2. Okay. So x is equal to negative 6 plus or minus the square root of 36 minus 2 is 4 all over 2. Okay. So that's negative 6 plus or minus, that's 2 over 2. Okay. So now we have two separate cases. We have the negative 6 plus the 2 over 2, and then we have the negative 6 minus the 2 over 2, because you know we usually get two answers. So over here, negative 6 plus 2 is negative 4 over 2, which is just negative 2. Over here, negative 6 minus 2 is negative 8 over 2, which is negative 4. So that's what I get for my answers. When you end up with answers that have no square roots and no i's in them, we'll talk about what i's are later. When you end up with answers that have no square roots in them, then you know that you could have actually factored it. So back up here, we could have just factored it. That's why you try to only use this when you can't factor. Plus and plus minus. Woo! That is not what we need to do. Sorry. M plus 2 is equal to 0, or M plus 4 is equal to 0. Same problem, same answers. Shorter if you can factor it. But you and I both know there were some problems in that factoring section that, oh my God, were hard and took forever to find out how to factor. So when you end up with stuff like that, you definitely want to go ahead and use the quadratic formula, even if it comes out like this, where you get pretty numbers, because sometimes that's faster than figuring out what the factoring was. When it's simple factoring like this was, piece of cake, go ahead and factor it. We're all good. But if it's complex and it's got a big A, et cetera, you don't want to be doing that. You want to just go ahead and use quadratic formula and be done with it. So you've seen me use the quadratic formula once. Let's see you try one. Did I mention you probably should have written that down? I hope you did. If not, you'll have to rewind. Okay. Let's have you try one. Go ahead and pause the tape. Let's see how you do. Remember, you need to pull out the A, B, and C first. Okay, so I hope you said A is equal to 2, B is equal to -5, and C is equal to -12. Remember, the sign in front goes with the number. So X equals, N equals, doesn't matter which one you use. -B, that's the opposite of this. That'll be a +5. Plus or minus the square root B squared. That's -5 squared. Minus 4 times A is 2. C is -12. All over 2 times A is 2. Once again, I didn't write it because I've already memorized it. I hope you wrote it until you get it memorized. So 5 plus or minus the square root of 25 minus 4 times 2 is 8 times -12. Ooh, that makes that a positive. 8 times 12 is 96. Over 4. $96 and 25 is 11. 122. 121. Oh, pretty number. Over 4. So we have 5 plus 11 over 4. And then we have 5 minus 11 over 4. 5 plus 11 is 16 over 4, which is just 4. 5 minus 11 is -6 over 4, which is -3 over 2. Yes, you should reduce. Always reduce. Okay. I hope you got it right. If not, I have another one for you to try. Number 12. Pause it. Let's see what you do. Number 12 had a little twist to it because before you could start, you had to make sure it looks like that. So we have to get this on this side. So that means I'm going to have 3x squared minus 8x plus 2, because when it comes over it changes signs, equals 0. Now I get to find out what my A, B, and C are. So A is 3, B is negative 8, and C is positive 2. Now I can plug it in and get that x is equal to positive 8 plus or minus the square root of negative 8 squared minus 4 times 3 times 2 all over 2 times 3. 8 plus or minus the square root of 64 minus 4 times 3 is 12 times 2 is 24 all over 6. 8 plus or minus the square root of 40 all over 6. Huh. We got this 40 here. It's not a perfect square into 40. But 4 goes into 40. Okay. Let's see what I can do with it. So that's 2 times 2 times 2 times 5. Since there's a 2 there, 2 on the inside, make 1 on the outside. This is all over 6. So this is really 8 plus or minus 2 square roots of 10 over 6. Now we're supposed to do our positive and negative, right? But we can't add those two. They're not numbers like they were before. So, in that case, we need to look to see if we can simplify stuff. If we could simplify stuff, then we could say what number goes into 8, 2, and 6. Well, 2 goes into 8, 2, and 6. And notice I'm not worried about the 10. I'm only worried about the outside numbers. Since 2 goes into all 3 places, I can take a 2 out of all 3 places because the 2 on top, once I factor it out, will cancel out with the 2 on the bottom. 2 goes into 8 4 times. 2 goes into 2 1 time, which leaves me with the square root of 10 over 3. Now, as far as Miss Rogers is concerned, this is a good enough answer. I'm happy with that, and that is useful to me. However, most books do not agree. And since I got to make sure you're okay with most books, I need to show you what they say. So, there are going to be books that are going to say this is really 2 separate fractions. This is really 4 over 3 plus or minus the square root of 10 over 3. They split it up into 2 separate fractions. Then There are some books who split it up even further, and they would say this is the same thing as 4 over 3 plus the square root of 10 over 3 and 4 over 3 minus the square root of 10 over 3. Some leave it like that. Some go and separate it even further so that you separate your plus and your minus into two separate answers. Because they want you to remember this is really two separate answers. You got the positive one and you got the negative one. Sometimes they actually don't separate it into two separate fractions, but they do separate the positive and the negative. So they might say 4 plus the square root of 10 over 3, and then 4 minus the square root of 10 over 3. That's correct too. There's nothing wrong with any of these answers. But this answer is the one that I use the most. It's the one that books probably use the least, but it's the most helpful, and it's the one that I like. Since I'm the one grading the paper, just saying. Now, the reason I showed you this is when you go to check your work in the back of the book, I want you to freak out because you end up with something different from what you have, even though you did it correctly. So make sure you understand that this could be what you see in the back of the book, any of these options. But this is still the same thing, and this is still okay for me. Okay? Notice we didn't stick it in a calculator to figure out what it was. I'm just saying you got to leave the square roots in there. All right, one more. By the way, that one, because we were left with square roots in our answer, totally not factorable. Only way you could do that is with the quadratic formula. There is no other method. Just saying. Totally not factorable. Number 22. Go ahead, pause it, try it. Let's see what happens. I hope that you said that you need to keep this number positive. So everything would have to move over to this side. Because remember, it's got to be equal to 0 before you can start using your quadratic formula. So that would mean 2p squared plus 4p minus 5 is equal to 0. Once again, not factorable. At least not that I can see right away. We get that a is equal to 2, b is equal to 4, c is equal to negative 5. X, p, whichever. Negative 4 plus or minus the square root of 4 squared minus 4 times 2 times negative 5 all over 2 times 2. $16 minus, because there's a negative there, that means it'll end up being a plus. So 4 times 2 is 8 times 5 is 40 over 4. Negative 4 plus or minus the square root of 56 over 4. Square root of 56 can be broken down into 2 times 2 times 2 times 7. 2 on the inside make 1 on the outside, all over 4. -4 plus or minus 2 square roots of 14 over 4. And then once again, 2 goes into everything on the outside. We can't get rid of the 4, but 2 goes into everything on the outside. So that leaves me with -2 plus or minus the square root of 14, because 2 goes into 2 one time. There's an imaginary 1 there, or an understood 1, I should say, over 2 on the bottom. And then you could write that all the other different ways that we talked about in the last problem. But I'm happy with that. So, time for classwork and homework. And did I mention this is like one of the most important sections in the book? The entire book. One of the most important. Because of that, lots of homework. Classwork. I'll tell you what page it is. It's page 552. You probably wanted to know that at the beginning, but it's okay. Page 552, numbers 1, 5, 11, 15, and 21. And then for homework, same page, numbers 3, 7, 9, 13, 17, 19, and 23. Lots of it. And it's okay that it takes up some space. It's okay if you have more than one column on a page. That's okay. All of this is fine, I promise. It's going to take a couple of pages. That's fine. Do your best. Write neatly so that you can find where your mistakes are easier. You should be good. I will see you, well, you will see me. It'll look like I'm seeing you next week.